Welcome to Brain Vision.
In this problem, we're going to be looking at something called lidar, which is light detection and ranging. Over here is a lidar gun. It's similar to a radar gun you might have heard about, except that it uses pulses of infrared laser light. So it sends out these pulses of light, which will hit a target. In this case, it'll be some car driving down the street. And when it hits that car, it reflects back, right? And it's reflected back towards the lidar gun and gets detected there some amount of time later. Now, the lidar gun, in the second instance, it sends out a second pulse of laser light some amount of time after the first one. And in that amount of time, the car will have moved, since we're saying that the car is traveling with some velocity towards the stationary lidar gun. So let's say the car moves some amount now. It's a little bit closer. And so when the second pulse is emitted from the lidar gun, it travels a smaller distance and returns to the gun in a shorter amount of time. And by measuring those differences, we'll be able to tell what this distance that the car has moved is. So let's call that x. So the car will move some distance x in the amount of time between the two pulses. So they told us that the two pulses are emitted 0.450 seconds apart. So over here, this distance x will equal the velocity of the car times the time that it's traveling that distance. That's this t over here. So things that we need to solve for in order to figure out the velocity. We need to know this distance and the time we already have. So how do we figure out that distance here? Well, we know that there's this original distance that the first pulse of light has to travel, d1 equal to its speed times t1, the time that it takes. And that's for the round trip. So for the beam to reach the car and then return back, it's traveling a round trip of d1 in a time t1. Likewise, the second pulse of light travels a distance of d2 equal to its speed c times t2, so a shorter time. We're told that the difference in those times, t1 minus t2, is equal to 1.27 times 10 to the minus 7 seconds. So that's how much quicker that second pulse of light gets to the car and back. So that's telling us how much shorter this distance is going to be. So let's go ahead and solve for t1 in this case. We'll say t1 is equal to t2 plus 1.27 times 10 to the minus 7 seconds. And now what we're able to do is plug that into our equation for d1 by substituting all that for t1 here. t2 plus 1.27 times 10 to the minus 7 seconds. And then we just distribute that c times 1.27 times 10 to the minus 7 seconds. And what we'll see here is that this term, c times t2, is the same as d2 over here. So I'll just substitute that into the equation now. This is d2 plus, now c times 1.27 times 10 to the minus 7, we're going to use c equal to 2.9979 times 10 to the 8 meters per second. Plug that into our calculator. We get about 38.073 meters. Scroll down a little bit. Oh, too much. Using that equation, we can now say that d1 minus d2, the difference in the round trip distances for each of those pulses of light, is equal to 38.073 meters. So that's the difference in their round trips, getting all the way to the car and back. Now this distance here, x, that's just the difference between when it first reaches the car. So the front end of the car and the front end of the car in this case. So it's actually going to be equal to just half of that distance that we found. So let's go ahead and take that and divide by 2 on both sides. And that's going to be equal to about 19.037 meters. That is our x, the distance that the car has traveled. So now we go back to this equation, x equals vt. What we're trying to solve for is v. So I'll write it back down here again. X equals vt. To find the velocity, we just take x divided by t. And now we know what x is, 19.037 meters. And we know what t is. That was the difference in time from when the first pulse was sent and the second pulse. So the front end of the car moves about 19 meters from the first to the second pulse, about 0.45 seconds. Plug that into our calculator, and you'll get about 42.3 meters per second.